Hi guys, welcome back. This is Professor Hank, and in this video I'm going to talk to you about templates in C++. Right? So let's get started. I'm going to start off quickly with introduction and talk about what templates are in C++. Then we're going to go through and take a look at how you can templatize functions. Right? And then after that we'll look at how you can templatize classes. And then we'll finish up with examining an algorithm, I guess you could say, for going about or how to get started on templatizing stuff, right? So it's a really simple procedure that that you'll be able to pick up really quick. Okay. Anyway, so let's get started. So introduction, templates. What are they? C++. They're a way for you to write C++ programs that are generalized. Okay, so you can write a function that can be used in multiple different ways. So, for example, if you wanted to write a function that could, maybe add a couple integers, okay, well, you could write a function that adds a couple integers in the usual way, right, where you have two integer parameters. But then if you wanted a version of that function that worked with floating point numbers, say doubles, well then you'd have to write a whole separate version of that function, right, where your parameter list has a couple doubles, right? And then if you wanted it to work with, shorts, I mean, whatever data types that you want to specify for that function, well then you'd have to make a different version of that function. You'd have to have multiple versions of it, right? Well, templates try to eliminate that. Okay, what they do is they say, well, you can create a blueprint for a function, and instead of specifying a primitive data type like an int, a double, float, whatever, you're going to make these generic parameters. Okay, and the compiler will tell when you call the function what it should use in place of those generic parameters, right? So those parameters will be kind of like little placeholders that we make in a blueprint, and then the compiler will create the function for us automatically, right? It'll translate it into your executable, to the actual program automatically when it encounters the function call, and it'll determine the data type of the arguments and then generate an appropriate function for you automatically. So you just make one function template, not 4 or 5 different versions of the same function. Okay, and so to do this, we're going to reuse the class keyword, right? But it's not going to be for making a class. It's going to be to specify these names of these parameters and these generic parameters, these placeholder parameters. And we're also going to have this keyword template. Okay, and then for classes, we can do the same thing, right? We can do a similar thing where we can create these blueprints for a class that will be generated automatically based off of, what data type you specify when you create an object of the class, when you instantiate a class and create an object in memory. Right? And so then at the very end, I'll show you an approach to getting started with writing a template. I mean, basically, the algorithm boils down to this, right? You just write your function, like, say, my adding function. You just write it using integers first, and then you just go through and you swipe out all the int data types for a generic data type, right? Okay, so let's go ahead and get started by writing a program. Okay, so let's go ahead and see an example of this, right? So, we'll write a function which I'll just call add. I'll keep the example simple, right? So let's say that we want to write a function that's going to accept 2 integers as its only argument, and then return the sum of those integers, right? So I could have something that looks like this, right? So have a prototype that looks like that, and instead what I want to do, right, is I want to make this into an actual template, right? So I want to be able to use this not just for integers, but say for floats, right? Or for doubles or whatever, right? So I don't want to make a complete definition. I want to use a template instead. So here's what we have to do. Okay, so what we're going to do is we're going to use this keyword template, and then we're going to place inside of these angle brackets, we're going to place the name of our generic parameter, right? So class T, right? By convention, as you could say that T kind of stands for type, right? So generic type. So if I wanted an add function that worked with anything, then I could write my function like this, right? So TATB, right? And so in the definition of the function, have something that looks like this: T sum equals A plus B, and then we'll return sum. Okay, so now this function is going to work. I only have to define that template one time. So this templatized function will now work for any data type, right? So, for example, let us say that I'm going to pass it a couple ints. So add 5 and 3, right? And then we'll see how that is. Okay, so let's go ahead and run that. Okay, so you can see the output there is 8. That's correct. Okay, now what happened? Okay, when the compiler got to this add function call, it looked at that and went, well, 5 is an integer and 3 is an integer. So I'll go ahead and generate the code for an actual function, right, in the program itself, in the executable. It didn't modify our source code. Just did this at compile time and said, all right, well, that's an int, so I'll just replace the T with an int in the function that I write automatically, right? And so the return type, I also made T, right? So the return type was also an integer because it matches what was assigned here, right? So can do that. I could also use the same definition to work with, doubles, right? So double D equals add 5.7 and 8.6. Okay, and then we'll see out D. Okay, so I've got, there's your answer, 14.3. So I've got two different calls, right? And the function call, or the function definition, only had to be written once because I used a template instead. And so for the second function call, the compiler looked at that and said, 5.7, well, that's a double. 8.6, that's a double. So that means that I'm going to have to generate a another function definition at compile time, where instead of having T, we're going to have double, right? So that actually creates two function definitions in the actual, I guess you could say, machine code. Okay. Yeah, so I mean, that's you keep on keeping on. And you could also do something like this, right? So it's not just limited to numbers, right? You could do this with any primitive data type, but also you could do this with other objects too, right? So for example, say I created a couple of string objects, right? So first and last name, say, okay? I could come down here and do something like this and say string full name equals add first last. Okay, oops. And then I'll do cout full name. Okay, so I can do that. Okay, and it's gonna work, right? So you're like, wait, what are you talking about? What? You're like, what's going on? How does that work? Well, when we make this function call to add this third time, what are we passing? We're passing two string objects, right? So it's as if the compiler at compile time, it's as if it wrote this function for you, right? And because that's basically what happened. And so since the string object has the operator plus overloaded, right, then no problem, because here what we're doing is we're doing concatenation with string objects, right? So you can do this, right? So first plus last, no problem, because string objects support that, right? They have that addition operator overloaded so that you can do that. And so no problem with using string objects with our template. Now, if you're going to pass objects to a template that you write, right? Say this wouldn't work for, if I wrote my own class and I didn't include an overloaded addition operator. Okay, if I fail to do that, then I'll get an error at compile time. Say I wrote a class named foo, and I didn't include that overloaded operator plus, and then I tried to pass two foo objects, compile time error. Okay, so you can do that. Now there's a couple of restrictions here, a couple of caveats. Another thing I'll mention is that if you specify this type up here, okay, then you have to use that type, that generic type, at least once in your parameter list. You can mix and match, right? You could put in here, like int x, for example, okay, and that's fine, okay. The thing is, though, is that you have to make sure that since you do have this generic type, that it's at least somewhere in the parameter list, right? So, for example, if I change these all to ints, then I'm going to have some issues. Well, I also have a return type here that I'm using also, right? So let's get them out of the definition, right? So now when I have that, I'll get rid of this too. Okay, you can see that my add function calls here are all broken now, right? So I can't use this anymore, okay? So you got to make sure that you use the generic type in here at least once. Okay. Let's see what else I want to say about this. Now you'll see that the add function calls here look fine, but now you take a look at add here, and I've got a problem, right? Well, the problem is that when I'm passing the two string objects, right, as arguments, right, the t will become data type string. And then the concatenation happens, but then that tries to assign a string to int sum, so that's not going to work, right? So then I got to change my data type for sum to t. And that still doesn't fix it, though, right? Because I'm returning sum, but what's the return type? An int, right? So got to make sure that all of your data types match, just like any other function. You got to make sure that you get them all straight. Now you can, like I said, you can mix and match. So in this case, that second argument is always going to be an integer, right? But you can also create additional generic arguments, okay? So that way your function can work with two different data types, right? So you could have, it's not just logged in anymore to say, well, I'm going to pass two floats, right? Could be that you do that, but you don't have to anymore, right? You can do two different data types, and so when the compiler looks at this, it's going to say, all right, well, A is going to be a float and B is going to be an int, okay? And so you can mix and match. And so what will happen with A plus B here? Well, an int plus a float is a float, and so then that will be assigned to T, which is an int, right? Because that's, or excuse me, which is a float because that was our first argument, which got assigned to T, right? And so then we'll return it as a float. So no loss of precision in that case. Yeah, so you've got all kinds of different options as to how you want to use this. And you can overload templatized functions with non-templatized versions. So I could have something that looks like, looks like this. Okay. And return x plus y, whatever. And so long as these two parameter lists are different, no problem. Templatized version, non-templatized version, the same program, no problem. All right. Is there anything else I want to say about that? I think I'll move on. Okay, so let's take a look at writing a class. Okay, so we'll write a class that is templatized. Okay, so we'll make a class called foo, and I'll have my foo class store a piece of data, right? And I want to be able to use this foo class to store any kind of data. So I'm going to reuse the same kind of syntax. So now in the class, you can use this generic data type instead of, primitive data types or any other data type. So by doing something like this, right, you can now use this class with any type of data, right? So we'll do that, and I'll just store one piece of data, and I'll have a set method and a get method just to show you how it works, just to keep it simple. Okay, so set, and I can say t, right? And I'll go ahead and set x to t, right? And then we'll have a getter method, t get return x, right? So now foo will work with any data type. Okay, so we'll go ahead and create a foo. Now this syntax is probably going to look familiar to you if you've done anything with, say, vectors, right? So you specify in these angle brackets what type of data you want this particular object to hold, right? So this is where you specify your replacement for that generic parameter t. So if I wanted this to hold an int, for example, then I'd put int in there, okay? And so now I can say f.set and then specify, you can even see in a little pop-up there it says int t, right? 95, and then I could see out f.get. And so we'll run it. And you'll see there's my 99, right? But I could also reuse this class now with a floating point number, right? So say double, and call it g, and we'll say g.set 99.99, and then see out g.get, right? So there's our 99.99, and then finally, even with strings, right? So we could do something like foo string h.set Hank, and then cout h.get. Yeah, just the h.get. Okay. So let's go ahead and run it. So you can see there's my name right there. So yeah, I mean, I just now have this class that I can use for any data type. All you have to do is specify when you create a variable of that type, what you're going to be holding within that generic variable, right? So this int right here is going to replace the t, right, for that particular foo object. The double right here is going to replace the t for this particular foo object, and then string is going to replace the t for this particular foo object. And you can mix and have multiple types, right, just like you could with function definitions. Okay. All right. So to finish up, let me go ahead and walk you through an approach that you can take for getting started with your templates, right? So whether it's a class, whether it's a function, especially if it's a class that's maybe a little bit more on the complicated side, what you can do is just start off with a regular old class or function, right? Don't even begin by thinking about templates, right? So if I was to create my class foo and I wanted it to store an integer, right? I might do something like that, and include my accessors and mutators, right? So something maybe like this, x equals I, okay, and then int get const return x, right? And so I do something, just with a normal old data type, right? Non-templatized version first, and then test it. So foo f.set line, and then cout f.get. Right? So if it works with integers, then I know that it basically works, right? The logic or whatnot. Now, I want to be able to reuse this class, okay? And this is a huge benefit of templates, is the fact that you can just write the template and then reuse that blueprint for all kinds of different data types, right? So what do I do? Well, what I'm going to do is I'm going to use that template keyword. I'm going to specify my generic parameter, and you can name that generic parameter whatever you want, right? T is just kind of like a convention. Okay, I mean I could name this kitten, because who doesn't like kittens, right? And so then you just take whatever that generic parameter name is, and then everywhere that you need to have that generic parameter kick in, right? You just replace it. So int x, I want x to be able to hold anything, so I'm going to replace the int with kitten, right? I want set to be able to work with my x, so I'm going to have to accept a kitten, right? Not just an integer, but a kitten now as an argument, because remember, when we create the foo object, that kitten is going to get replaced by whatever we put inside those angle brackets. Okay, and so I'm going to want to return a kitten as well. So storing a kitten in X, and kitten's just a placeholder. It's going to be a string, a float, a double, an int, whatever. And we want to be able to accept one of those as an argument. We want to be able to return what we're storing. Okay, so now when we go back to main, we can specify in here, oh, we want to work with integers, right? And so now it's going to work with integers, right? Or I can say, well, I want to work with strings. Okay, and if I work with strings, then I've got to pass a string. Right? And so now the class works with strings. Okay, so that's just the kind of an approach that you can take, because when you start making all these different template generic parameter names, right? It can get kind of confusing when you're trying to work out the logic for your function or for your class, and it just could be easier to get everything working with just an int, right? Just something simple. If it works with one data type, then you can generalize the class. You can make it more generic, right? By using this template technique, right? This template feature in C++. Okay. You can also inherit from templates as well. So I could do something like this, right? So it's called bar, and we're going to inherit public access specifier class foo. Okay, and we have to specify type name, right, inside of there. Let's not forget our keywords up here. Okay, so there we go. And maybe I just want to add a single method here, like I don't know, we'll call it double or something. Get double, right? And maybe all we want to do is return twice what's stored in kitten. Okay. Let's go ahead then and create a bar of make it an int, right? And then we'll just do b.set 9, and then we'll call the get double, b.get double. Right, the double it. Now, for our get method, we're going to have to specify that it is inherited from class foo, right? So, because there's nothing here, I mean, the compiler will get confused because there's nothing here that says that it's a template, so it doesn't necessarily know what to do with it, right? So what we have to do is we have to say, oh, well, this is coming from foo, and this is the data type that we want to work with get, right? So we want to use the get that is templatized, a templatized version of get that is defined up here in our foo class. Okay, so you got to specify here that generic parameter as well. Okay, so let's go ahead and take a look at it. and then you can see there's your 18. Okay, so I think that's everything that I wanted to show you. So just to summarize, what did we go and do? Right. Well, talk to you about what templates are, what their benefit is, showed you how to templatize functions, and then showed you how to templatize classes, and showed you how to even do inheritance with templatized classes, and showed you an approach for going about and getting started with writing templates. Right, just start off with a regular old basic primitive data type, make sure it works with that, and then convert it into a template. So write the class for an int, for a double, for a float, or function, and then convert it. Right, just everywhere you see that data type, int, float, double, whatever, convert it to your generic parameter. Okay. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up, and if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.